In problem number 51, we are asked to factor this binomial, this two-term expression, and to do so, let's look to see what's common. So first of all, between the 33 and the 9, there's a 3 common, so we're going to factor out the 3, right? 3 is the largest number that divides into 33 and 9. So let's factor out that 3, so we'll take a 3 out. And then for the y's, we've got 11 of them here, 5 of them here. So we have at least 5 y's in each one. So we'll factor out the y to the 5th. So if we take out the y to the 5th, now remember when we factor out with variables, we always take the one with the smallest exponent because there's at least that many in both of these terms. So what's going to be left here? So what we're looking for is 3 times what will get us back to that 33. So do a little division. Positive 33 divided by that 3 is 11. And we started here with 11 y's and we removed 5. So if you do a division, right, take this, divide it by this, we know we subtract the exponent, so it's going to be 6. And that makes sense because we started with 11 y's and we removed 5. There's going to be 6 left, so we're going to have y to the 6th. Then, what about over here? 3y times what is going to be 9y to the 5th. Well, 3 times what is 9, so do a little division. Positive 9 divided by positive 3 is positive 3, and there were 5 y's to begin with. We removed all 5. So we're going to be left with this expression right here. And we could check this. This is what we're going to claim as the factored form. We could check this by multiplying back through. So 3 times 11 is 33, y to the 5th times y to the 6th, add the exponents, get the 11th. 3 times 3 is the 9, y to the 5th. Problem number 53 asks us which is the actual proper form. Well, if we tried to factor this, look at what's happening here. What's common between 19 and 64? There is no number common that divides both of those. And there's 4 y's over here, there's no y's over here. So in fact, there is nothing in common, so we would just write, according to what we're asked, no common factor, or this expression is already factored. Now, in problem 57, we're actually asked to factor this expression, so let's take out constants first. So between 13, 39 and 91. Now 91 is a little tricky because it's such a high number, but here's what I do know, between 13 and 39 there's at least a 13 in common. Then on my calculator I'm going to take 91, divide it by 13, and sure enough it comes out to 7. So 13 is common to each one of these numbers. So let's take out a 13, and now let's go with these x's. There's 8 here, 4 here, and 2 here. The smallest exponent being this 2. So there's at least 2 x's in each one of these terms, so let's remove that x squared. Now, if we do that, here's what's left. Do our divisions here. 13 times what will give us 13? Well, division, 13 divided by 13 is 1. And as far as x's go, there were 8 to begin with. We're removing 2, so there's 6 left. Then 13 times what is going to give us this second term here. Do a division. Positive 39 divided by positive 13 is positive 3. And there were 4 x's to begin with. We're removing 2, so there's 2 left. So we'll have 3x squared. And then, by our calculator, we're going to get negative 91 divided by positive 13. That's a negative 7. And there were 2 x's to begin with. We're removing both. So I think we've got this done. And let's draw our parentheses and claim that this is the factored form. And we could check that by multiplication, and you can do that if you like. In problem number 63, we've got these 4 terms, and as we look through them, what's common here? I've got x's here, but there's x's here, 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 and here. So x is common all the way through. And in fact, how many are there? Well, there's 9 to begin with. I've got 9 here, 7 here, and only 1 here. So there's an x common, so let's remove the x. Now, what else, if anything else? Well, there's only an x here. There's no y's. I got a y here, and y here, but there's no y's all the way through. So I think this is going to do it for us, so let's see what's left. Now, if there's 9 x's to begin with, and we remove 1, there's going to be 8 left, so we're going to have x to the 8th. And in this term, if we take out one of these x's, what's left is that 8 x's, and then the 7 y's. So we're going to have plus 8 x to the 8th, y to the 7th. And then over here, take an x out of here, that gives us 6 left. So we're going to have minus 48 6x, x to the 6th, so 6 x's, and then y to the 6th, and then plus 32. Now, there's an x here, but we're removing it, so what's left there is a y. And that's going to be it.